Hello, welcome to Philosophy Roulette number 130. And yeah, that's where we get philosophy off the internet and read it and review it live. And so, this is the front page of Phil Papers. Let's see what's new in the world of world of philosophy. Agriculture and human values. How do you publish so much agriculture and human values? Applied ontology. I fear that's going to be too technical. Axiomates. Ooh. Read stuff from them before. Oh, shucks. This is built-in philosophy medieval. Medieval philosophy. That would be cool. Should try to get something off of them. Hopefully it looks like some of these might be in French, and I can't read French. Try it. Alright, so. So we've got, let's see. Yeah, I'm a tad concerned that I won't be able to read anything from this journal. Formal ontologies and manufacturing. These might be a little too technical. Let's see what we got here, though. If anything. Ooh, is this open access journal? Maybe. What did that say? Press content library. I don't know. Huh. 7 pages and I don't know what, yeah. Yeah, this is sort of technical stuff. I don't know. Yeah, this is sort of what's it called? I mean, it's all text, but it's not a I don't know. Maybe I could take a look at one of these. I'm not really sold on this yet. Because I just applied ontology is a little it's sort of a like buy and sell different. Let's see, you've got verbs buy and sell and other interpretations of events. So you're talking about how technical things can be used to represent concepts, and so it's more of a computer science problem, like language, cognitive science, artificial intelligence. So it's not exactly. But who knows, maybe I should take a look at this. Yeah, it just looks a little too sciencey at the moment for me, which is cyber physical systems. Ooh, that sounds cool. That's a special issue. Formal ontologies in manufacturing. Editorial. Not helpful. Let's see what Axiomates got. I may come back to that meaning and applied ontology, although it looks more technical than philosophical. Quantifier variance without meaning variance. 12 pages. Well, let's take a quick gander at that again. Awful technical. Fractional calculus will be applied. Fitch and Mary. Let's see what that is. The weak 3-value logic. I don't want to talk about 3-value logic. So this is City and Soul in Plato's Al-Farabi. Did I read this one? I don't know. Virtuous City, maybe not. How to overcome anti-real objections. I did read this one though. So that means I've already looked at all this stuff. Let's see what... Oh, I didn't look at the new stuff in Axiomates. That's what I should have been looking at. Let's see. Red cube. Oh, no, is this one of those I can't download it again things? Well, let's go see how many quantifiers are in this, because if I have to keep reading quantifiers, I'm just going to be like, nope. Because like quantifier 1, quantifier 2, quantifier 3. That's not terrible. Alright, let's see. Let's see if I can get it or not. Alright, so, no, but that annoys me. Fiction Mary, let's see. Nope. Alright. So, on the City and Soul. So it's this one. This one, not this one. Although this one looks like a different. Well, let's see what they wrote on this in this other journal. I mean, it looks like something else. Oh, nothing in Bullet of Philosophy. That was gonna be. I was excited about that. I want to read some. All right. Is this the Bullet of Medieval Philosophy? Okay. Duns Scotus. Thomas Aquinas. See, I was like, this is all gonna be a lot of fun. Oh, okay. So let's see. We've got 4 pages here. What is this? Let's see. That's what I was looking forward to, is maybe reading some medieval philosophy, not some of this technical. Well, it could still be technical. What is this? Oh, this is a critical notice of a conference. Okay. Let's see what this is. Well, maybe that's what all of these are. Yeah, this is, okay, so this is a bulletin in the sense of this was a review of what has been going on in medieval philosophy in these different locations. So Pisa, Leuven, who's Eckhart and Significate? So maybe those were those. Let's see. Yeah, so none of those. Aquinas on mixed actions. And again, logic I can't do because it's just not 22 pages. Sorry, not getting read right now. This is 19 pages. Not getting read right now. Oh no, that's so sad. I was so excited. I was like, I get to read something about like medievals. Yeah. Another 20-page paper. Okay, so Dagnabbit. What do we got? Alright, so this one was what? This is 13 pages, but technical. Yeah, trying to get some non-technical. I don't want to read technical right now. I was thinking too technically this morning. Alright, so what can I do? Did I look at the Aquinas and mixed actions? Probably. Let's see if there's anything else here I can find real fast. Did I do Eckhart? I don't even know anymore. Yeah, this was 19 pages. I will take a look as fast as I can. And I have to sign in. Okay. Sorry then, not any of these things. None of that happening. Shoot. Now imagine an actual existing unicorn. Okay, my Nongianism. It's a little bit long again, but what are you gonna do? 1 to 11. Quantum epistemology from mimicry and ambiguity on the composition of fourth. Algorithm and experiment. Alright, so is there anything shorter? Please be shorter. Okay, so no such luck today. So let's see what we got here. PDF Springer, what is this? Is this actually... Oh, you can get it. Cool. Okay, so we've got 16 pages of very small font and very small margins on the page edges. Yeah. Alright, this one's shorter but incredibly technical and impossible to read. Oh dear, I've spent my 10 minutes I usually spend for trying to find a paper and I can't find anything. Oh no. Alright, so we're going to be doing one of these other ones that I was somewhat avoiding. So, alright. That's what happens. It's roulette. Okay, so we've got quantifier variance without meaning variance, and I can't download it. Oh, I hate this. Because this sort of... It's like I can read it, but I can't comment. I can't make little notes on it. Okay, so that's what it'll be, though. Let's see if I can get a better copy, too. But we're doing quantifier variance without meaning variance. Some very technical stuff. And if you want to get the link to this paper or this page, you can type !" paper in the chat box if you're here live. If this link is still not here. Okay, so we are just therefore stuck with the online version. Okay. Is there any... Let's see, can I zoom a little bit more? Okay, I can't zoom. Okay, there we go. So, we're doing this paper in Axiomath. Hirsch defines what is this? Hirsch defines quantivariance QV as the view that the world can be correctly described using a variety of concepts of the existence of something. For example, there exist tables is true using one concept, for example, the quantifier of compositional universalism, and false using another, the quantifier of compositional nihilism. Regimenting the existence of something by means of quantifier expression there is, or equivalently there exists, QV, is a rejection of the view that there is a metaphysically privileged concept of existence, God's quantifier. Yeah, and some people take out the exist entirely and just say the backwards E is a sum. So you don't even have that. You don't tie the existence to quantification. So, I mean, this view is not... You can even get away farther from the view because you can just remove the existence claim from quantifiers entirely. Okay, anywho. Quantifier variance is thus associated with a negative doctrine about the meanings of quantifier expressions. From a metaphysical point of view, there is no unique metaphysical distinctive meaning for there exists. Yeah. It is characteristic of quantifier variance that quantifier expressions are not equivalent, that is to say, they disagree on the truth value of some sentences. For instance, in a nihilistic language, Hirsch's typical example, namely, there exist tables, turns out to be false, while in ordinary English it is obviously true, other things being equal. QV, to be sure, is not the crude claim that the truth value of there exist tables depends on what there exists means in a particular language, which is a truism. Obviously, there exist tables is true in the plain sense of English, in the sense of plain English, and if a language L there exists means what David and his colleagues are means in English, then there exist tables would be false in that language, partly because of the evident fact that David and his colleagues are not tables, other things being equal. Maybe they are. I don't know who David and his colleagues are. However, this does not entail that the quantifier expression does not have a metaphysically privileged meaning, because in L, there exists, which is synonymous with David and his colleagues are, in English, is not a quantifier expression. Indeed, QV amounts to a subtler view. All the meanings assigned to there exist are quantifier meanings. Equivalently, alternative language contain quantifier expressions, none of which are metaphysically privileged. Okay, so we've got some sort of quantifier meaning and quantifier expression. And so we'll see how that cashes out. This leads to the problem of explaining in what sense all these expressions are quantifiers. Yeah, if you define them differently, are they all the same thing? If there is no such explanation, there seems to be no limit on how much the meaning of quantifier expressions vary in alternate languages. However, as illustrated above, if the meanings of quantifier expressions vary completely, QV suffers from triviality. Therefore, the problem of how QV can be maintained without falling into triviality. Let's refer to the thesis that the meaning of quantifier expressions vary completely as meaning variance. The undergoing problem, thus, turns out how quantifier variance can be maintained without meaning variance. And so there's the problem of MV. This is the problem I am concerned with in this paper. Section 2 presents Hirsch's original comment on the problem of MV and its notorious shortcoming. In Section 3, I propose a solution to the problem, which is inspired by Hirsch's original comment. Section 4 presents the underlying formalism of Section 3 more explicitly. Section 4 is devoted to objections and replies. You know, everyone does this. They give this little signposting thing at the end of their introduction. I'm wondering, like, is it like a requirement now of papers that, like, you kind of do something like that? I don't know. It's just, it's interesting in the philosophy papers because they are not, I mean, they're meant to sort of outline what's going on, but it just sort of, I mean, how necessary is that? It does make it seem somewhat like, I mean, you could just look at the section titles too. Anyway, it's an interesting thing about current writing and academic philosophical research. Hirsch was well aware of the problem of MV at the early days of QV and left some comments on how to overcome it. Why is Hirsch? I don't know, Hirsch. I wonder if the person's dead. It's like you left some comments to how to overcome it. It's like this was just their something in the notes. Oh yeah, this is the solution to this, but I'll get back to it later. Hirsch's last theorem. To say that even after there has been a change in the meaning of quantifier expressions, we still have a kind of quantifier expression and a notion of existence is merely to indicate a degree of similarity between the concepts we started with and those we ended up with. It seems clear that the imagined change in the meaning of the expression, there exists something, will leave the expression's general role in the language largely intact. In particular, the purely syntactic and formal logical properties of the expression will not be changed at all. The formal principles of quantificational logic will be unaltered. Yeah, the principles of logic will be unaltered, but there's a lot of ways to cash out existence. As I said earlier, you can even get rid of the existence from the quantifiers. And so that would take out the existence from the logical properties. So there's a question of, yeah, so let's see where they're going with this. Here, Hirsch proposes a solution to the problem of MV. Quantifier expressions in various languages are quantifiers because they all have the same formal inferential roles in their respective languages. Formal inferential roles. See, I can't highlight here. That's so annoying. However, the question of what the formal inferential roles of quantifier expressions are remains to be answered. A natural candidate, apparently suggested by Hirsch himself, is a set of classical logical introduction and elimination rules governed by quantifier expressions. Although this is a vague and underspecified comment, I believe that it presents the right approach to the problem. I call a variantist who adopts Hirsch's solution to the problem of MV a Hirschian variantist. My aim in this paper is to elucidate and defend a version of Hirschian variantism. Let me begin the discussion by a notorious argument in the literature implying that the formal rules of introduction and elimination cannot play the purported role. This argument dates back at least to Harris 82 and Williamson, however many include Sider, Hale, and Wright. Eklund restated and developed the argument directly against QV. Here is a version of the argument. Suppose that there are two quantifier expressions E1, well, backwards E1 and backwards E2, in two different languages L1 and L2 respectively. Furthermore, suppose that these quantifier expressions both obey the classical rules of introduction and elimination, and that these languages have the same set of variables. Now, in the unified language, L no subscript is the union of L1 and L2, so you've got the like a big language. Okay, so you've got logic. Basically, you instantiate from the existential quantifier backwards E sub 1 to an instance of just f of x, and then you Then you just introduce the second quantifier of E2 from the same thing from line 1. Okay, so therefore you can switch out the types of quantifiers once you have a larger language. Okay, so therefore existence is why I did so hard to say. Existential sub 1 quantifier x of f of x entails existential 2 sub 2 x f of x. The other direction is parallel, so hence E1 existential 1 if and only if existential 2 for some x f of x. This is a very simple argument against the idea that there can be more than one quantifier expression satisfying the purely syntactic or formal properties, up to logical equivalence, provided that the formal properties are rules of introduction and elimination. Well, this also assumed that you have the same objects in the two languages and you're in the same universe. If you're quantifying over different sorts of objects, then maybe you can't just existentially generalize on the first domain of objects with the second kind of existential thing. So it's like you're saying we're quantifying over, let's just go some sort of dualism. We got physical things and we got mental stuff, mental and physical. So there exists some concept x1 that has property f of x. So then the object, you say you instantiate to object A. So there's some mental concept A that now is f of A. And then you're saying, well, then there is some physical stuff, and you're trying to existentially generalize on that. So you shouldn't be able to say there is some physical stuff, like there exists some physical stuff x because of f of A. You're generalizing on the object, the mental object with a physical quantifier. So I think there might be some issue with how the overlapping variables here has a built-in presupposition of a unified domain. The unified domain might have something to do with what's going on here too. So anywho, a Hersheian variantist might resist the argument at the beginning step by rejecting the claim that there could be a unified language. Okay, that's fine. That's what I was sort of getting at. Unified language L that simultaneously contains these two quantifiers. It seems reasonable that from the variantist perspective, this requirement cannot be fulfilled. As Hersh suggested, these alternative languages are alternative legitimate descriptions of reality. There is no God's viewpoint justifying the adoption of the unified language over and above these two languages. Therefore, there could not be any unified language describing reality. It seems, nevertheless, that this position is unstable. As Sider notes, formally, if these languages L1 and L2 exist, one could introduce a third language containing symbols backwards E1 and backwards E2 for the quantifier meanings in the first two languages. The challenge is explaining why, from a formal perspective, there could not be such a unified language. No convincing response seems to be readily available. The Hersheian variantist has no choice but to concede the existence of L, at least from the formal point of view. How then the Hersheian variantist is supposed to block the collapse of argument? Yeah, I mean, from the formal side, you have to come in, like I was saying, with a philosophical thesis that you have two different sorts of things, but the mental and the physical to try to keep the quantifiers apart. But if you're from the formal side, you can't do that. There is no difference in variable from just the syntax point of view. You have to have a philosophical reason for doing that. Okay, so a Hersheian solution. An alternative response by the Hersheian variantist is to reject the assumption that L1 and L2 share the very same set of variables. I love it. Well, I do know something about this area, so it's like, I shouldn't be so proud of myself for getting something right. It's like, okay, I kind of had an idea what would happen. They share the very same set of variables. Not only do these languages have non-equivalent quantifier expressions, but they also must have disjoint sets of variables. Yeah. This is why I was avoiding this paper, actually, because I was just thinking about this stuff literally not 10 minutes before I came to sit down to broadcast today. I was looking at something that had to do with this. I was like, all right, I was just thinking about this stuff I don't know anything about right now. And it's like, when now I'm like, okay. Yeah. Each quantifier only binds variables that are relevant to that quantifier. For example, the set of variables L1 is, alright, so we're superscripting these variables with, the L1 is superscripted 1, and the set of variables for L sub 2, language sub 2, is superscripted variables x to the x superscript 2, y superscript 2, and each existential quantifier sub I can bind only to superscripted variables for the corresponding i's. The collapse argument is then to be formulated as follows. Okay, so you can't do it because this is illegitimate, because if you really care, you can look at this 4-line not that well formatted, I must say, I'm sorry, proof. Obviously, existential 2 introduction is illegitimate since existential 2 cannot bind to x superscript 1. Hence, this formal qualification, the collapse argument fails. I mean, are you just defining yourself out of the problem here just by saying we have different stuff? Maybe, but then again, there's good philosophical reasons to do this. It's just you have to have them. Okay, therefore, the basic formal idea is to restrict quantification rules within the scope of local variables. This is the hallmark of many sorted languages and logics. Yeah. Many sorted languages are those in which all variables, terms, predicates, and quantifiers are sorted. Each quantifier is associated with the variables and terms that are of the same sort. Semantically, there are more than one domains of quantification, one for each sort. Domains are probably, but not necessarily, disjoint. Each quantifier ranges over a domain that is associated with a particular sort, and finally the introduction and elimination rules of quantification are restricted to the relevant sorts. Let me pause and take stock. The main problem under consideration in this paper was the problem of MV. What is it that explains that quantifier expressions in different languages L1 and L2 are quantifiers? The Hosseini variantists claim that the answer is that they are quantifiers because the set of formal rules governing them remains intact. The opponent presented the collapse argument against the suggestion. In reply, the variantists proposed that the unified language is many-sorted. Although this last proposition blocks the collapse argument, it does not solve the problem of MV. The reason is that the set of formal rules governing the quantifiers in the languages, respectively, are not literally the same, since the rules governing each quantifier sub I, for all the different numbers, contain quantifiers of the sort I, and by assumption L1 and L2 do not share their variables. The problem now is explaining what Hosseini variantists could possibly mean when they claim the set of formal rules remains intact. Yeah, because you'd have to have a rule for each one of these. So I'm sure you could generalize over it, and that's where we're going, but as of right now, if you have things that talk about different objects, like mental stuff and physical stuff, and they only work for each one of the different quantifiers, then it is a different rule because each quantifier has a rule for itself about what it can range over. Here is a suggestion. Like before, think of the languages L1 and L2 with two separate sets of variables that contain E1 and E2, the existential 1, existential 2 respectively, and the unified language L, the union of the other languages. Consider the classical introduction rules for existential 1, existential 2, and the unified many-sorted language in which x superscript 1 and x superscript 2 are of different sorts. So we've just got existential introduction of type 1 when we've got a type 1 variable, and you've got existential introduction 2 when you've got a type 2 variable, object, really, here. What is it that explains why these rules are both classically introduction rules for the sorted existential quantifiers? Intuitively, the answer lies in the fact that these two rules have the same form. Roughly speaking, the shared form is that in each rule, the premise is a sorted formula containing a free variable of a sort, and the conclusion is a sorted quantified formula containing a particular quantifier of the same sort, following the variable and the sorted premise. In other words, by eliminating the information about the relevant sorts of expressions, there remains no difference between these two rules. Both rules share an abstract description, introducing an existential quantifier into a formula. Regimenting these ideas amounts to associating a Kaplanian character with introduction and elimination rules of sorted quantifiers, that is to say, associating a kind of non-indexical character with those rules. The Kaplanian character of an indexical roughly is a function that takes the context and gives the referent of the indexical in that context. Furthermore, the content of an indexical, according to the Kaplanian approach, is divided into two factors, a character and a context. And finally, the character of an indexical is content independent and remains constant during various contexts. All these features have counterparts in the case of sorted rules. Each character of a sorted rule is a that takes a sort and gives a relevant sorted rule. Furthermore, the content of a sorted rule is divided into two factors, a character and a sort. And finally, the character of a sorted rule is sort independent and remains constant during various languages. Okay. At this stage, we can see how a Hersheyan variantist can be understood. The variantist is committed to the claim that the set of rules governing quantifier expressions in different languages remains intact. My suggestion is that what literally remains intact is the character of the rule governing different quantifier expressions. In other words, although the sorted introduction or elimination rules are not literally the same, they are the same in the sense that they have the same character. All right. So basically, the author here has abstracted away a little bit from the index and said, well, look, we're not really doing anything different because the indexes are of a kind, and so or of a character, and so as long as you're still using quantifiers that use this index of a character, even though the character itself is not the same, they're all of a type of character, even though the objects within them are not. I don't know what exactly this Kaplanian, how this actually shakes out, this Kaplanian character of an indexical. I'd worry that, because if it doesn't look like they're going to give, I mean, they may give a formal treatment, but I mean, the devil's a lot of times in the details of this stuff, and so without giving the formal stuff to go along with this, I'm a little worried, but I mean, it may not, for all I know, it's completely trivial. But then again, this is a philosophical argument here, not a formal showing, like, look, giving a more generalized quantifier of this. So, I don't know. Let's see. Full treatment is deferred to the next section. Let's see, where is number 9? Okay, so maybe they're just going to put the logic later, so, which is fine. You might as well just say your stuff and then put the formal bit afterwards. Okay. Consequently, we have a reasonable solution for the main problem under consideration, namely the problem of MV. The sameness of the characters of rules governing the quantifier expression explains why they are all quantifiers. It's worth noting that this sameness of character does not make the quantifiers equivalent, since we saw how the suggestion blocks the collapse of argument. QV is thus sustained without MV. In the following section, I formally articulate what was discussed here in the form of rough and ready statements. Yeah, I'm just a little worried that this just pushes the problem up a level. So you don't have, so you can talk about quantifiers that range over types of objects of the same character, and then you can split them up, you can sort them out into different characters. Then you've got different rules for quantifiers. And then, so you've got like a bunch of quantifiers, but then what's this meta quantifier that you're talking about? Is this some sort of second order quantifier? We're quantifying over quantifiers here. So are we really just going second order logic here? What is, so, yeah, that's a little beyond me, some of that stuff, but, oh no, we're just going to be doing lots of logic here. Yeah, maybe, maybe not. Yeah, it looks like maybe second order variables, quantifiers. Alright, the underlying formalism. Let I be a set of sorts and language sub I, such that I is an element of big I, a collection of sorted languages. Dearie, am I just going to be reading formulas for the rest of the day? Maybe. Each L sub I contains a sorted quantifier backwards E sub I and an innumerable set of sorted variables X superscript I for every I in big I. Let L sub I S, share their set of predicate symbols and contain no function symbols and constants. Each language has its own classical proof system and semantics indexed to its sort. Note that no restriction on the sorted domains of quantification is forced. Sorted domains may or may not have non-empty intersections. Now let L star be the many sorted languages containing all Li. So this L star is the big language with everything in it. We say that L star is the mere aggregation of all the other languages if and only if each set of symbols is set of symbols, each set of symbols of L star, the big thing, is a union set of all the sorted symbols. So you just take the union of everything, but no new interaction between the sorted languages and the various sorted proof systems and semantics of L sub S is allowed. So you don't get anything new when you group everything into the big language. Particularly in the language L star, the total language, the no sorted quantifier. Particularly in the language of L star, no sorted quantifier can bind any variable of other sorts in the semantics of L star. No sorted variable or constant can be assigned to sorted objects in other sorted other sorted domains unless there is an intersection between two relevant sorted domains. And in the proof system of L star, no sorted quantifier can be substituted by the variables of other sorts. So everything, even though when you throw it into the big language, everything plays nice. Everyone plays in their own yard basically here. So, or they stay in their own neighborhood. Like, so even though you've got one big town with all the language in it, all the objects sort of stay in their own little neighborhood in the big town. I mean, as you know from reality, that never completely accords with reality, but you can have an idealized system like that. Let L star be the mere aggregation of all the languages. The language L extends L star by a denumerable set of abstract variables x, y, and an abstract quantifier, just no subscript and no superscript, an abstract introduction rule, and an abstract elimination rule, all associated with the non-indexed backwards E. There is no change in the proof system and the semantics of L star. An abstract variable alpha is a function that assigns to each sort the corresponding sorted variable, and the abstract quantifier is a function that assigns to each sort the corresponding sorted quantifier. Yeah, so this is basically a second order quantifier that assigns the right sort of quantifier in the right case. Okay, so it's a function that assigns the right sort to the things depending on what they're talking about. Okay, the notion of an abstract rule is a bit subtler. The abstract introduction rule is a function that takes a sort and an abstract variable and gives back an introduction rule for the relevant sorted quantifier binding the relevant sorted variable. Likewise, the abstract elimination rule. In the following definition, this formula and that formula are sorted introduction and elimination rules, and which contain alpha superscript I as their bound variables. Okay, so we've got stuff. Alright, so basically it takes, for introduction, it takes the variables and puts it into L, and then otherwise, and that way you can have it. And then elimination, it's all the same stuff. It's just you've got these abstract variables that find the right sort of variable. It's sometimes a problem, actually. I had to go from second order variables to first order, but it's not that bad. The notion of abstract variables and abstract quantifier are instrumental in order to define the notion of abstract rules. The guiding intuition for the foregoing definition of abstract rules is related to the rough description stated in the previous section. An abstract rule is supposed to be the form shared by different sorted rules, that is, the Kaplanian character of the sorted rules. Therefore, we require that rules that merely differ with respect to sorted variables, with or without the same relevant abstract variable, be not associated with different abstract rules. For example, in addition to rules A and B, rules A and C should have the same abstract introduction rule as well. So what is the difference? Nothing much. It's just if you have a rule for X, it works just the same for Y. Yeah. So there's two kinds of abstractions here. The variables themselves are different objects abstract over actual objects, and then you've got sorted objects. And so even between those, so it can handle different objects just the same as the sorted variables handle multiple multiple objects with underneath them. Okay. It should be known that many sorted language L, abstract variables and the abstract quantifier and abstract rules do not have any proof theoretic or semantic role by themselves, independent of their sorted counterparts. Therefore, there would be no difference between the kind of many sorted language introduced here and the well-known many sorted languages with respect to proof theoretic and semantic features. The only change made is in the many sorted language. The upshot is that the introduced many-sorted language benefits all well-established meta-theorems and meta-sorted languages, including soundness and completeness. Okay, objections and replies. Okay, in this section I consider possible objections to the proposed version of Hersheyan variantism and make some comments on how to overcome them. First is a well-known mathematical result that many sorted languages can be translated into unsorted languages so that the two corresponding languages have equal expressive power. Details aside, the idea is simple. Just add some predicates for any sorted domain and relativize any sorted claim to the relevant predicate in the unsorted language. The worry is that if QV is articulated by means of a many-sorted language, then it will be a variant of ontological realism, which is its rival thesis. Here's an alleged explanation. Ontological realists, such as Sider, claim that there is a unique answer to the question of ontology, namely, what is there? The ready-made choice for the logic of ontological realism is the unsorted first-order classical logic. Now, if the logic of QV is supposed to be many-sorted, then because of the mentioned mathematical result, the logic of QV is nothing but first-order logic in disguise. Consequently, QV turns out to be a variant of ontological realism. In reply, the variantist can maintain that the mathematical result, although true, is not decisive. Here is an example from another context. It is a familiar mathematical result that a modal logic can be translated into a non-modal language that quantifies over possible worlds. This by itself does not imply that any theory of modality is a variant of Lewisian modal realism. Even Lewis himself did not take this line of argument for his modal... Oh man, somebody with an idiot is driving a truck very poorly outside. They might get into an accident. It's like, don't look over there. There's a window behind this monitor, so I can see the street. This is... Yeah, it's like, yeah, I'm gonna just be over here for a little bit so I can't see this impending doom. This by itself does not... Oh god. This by itself does not imply that any theory of modality is a variant of Lewisian modal realism. Even Lewis himself did not take this line of argument for his modal realism at face value. Instead, he made a lot of effort to show that his theory of modality has more explanatory power compared to its rivals. Kind of. It's like, you can, okay, the dude made it out reasonably unscathed. I don't know if he maybe bumped his, oh, now he's getting the other side of the street? Yeah, his, bumper. Okay. There's a question here that maybe in the concept of, quantify over possible worlds, non-modal language quantifies over possible worlds, what the objects are on your first order. And so there's a problem here because you're quantifying over these meta objects. And so what sort of ideas have you built into the objects? So even if you can translate in, you may have snuck in some more conceptual work into some of these other concepts. And so I think the author here is trying to say, look, even if the mathematics holds, it doesn't mean that nothing new has been introduced, because the predicates at that point, like if you're quantifying over possible worlds, then maybe there's more built into the objects themselves and you've still got it. It's just sort of embedded somewhere. Maybe, I don't know. But like that seems like there might be a... Like, that. I guess the fear is that, yeah, it's all just window dressing. There's nothing but first order logic in disguise. Yeah, but maybe the disguise matters, I guess you could say. The disguise is worth something. So it's you're still getting something new, just it happens to be disguise. But it's not really, I mean, the first order logic with disguise, not in disguise. But like, the disguise matters. Okay, so maybe, I don't know. Yet another example is the nominalistic translation of mathematical sentences used in science, such as Field's translation of gravity into an arithmetic-free language. Arithmetic-free language. Clearly, this translation, even if successful, itself does not entail anything for his anti-realism or against mathematical realism. Even Field, who is regarded as the founder of the translation, did not draw such conclusions solely from the existence of this translation. Other considerations, such as Occam's razor, are required before favoring anti-realism over realism. Generally, translation and the equivalence of formal expressive power are one thing, and the identity and the rivalry between theories are another. At best, a translation manual gives a systematic formal translation algorithm between sentences of two rival theories. It does not entail that these two theories are the same. Worse, it does not entail that one theory should be reduced to another, since translation manuals are usually symmetric. When discriminating and choosing between theories, other factors such as explanatory power, simpleness, naturalness, fundamentality, etc. play significant roles. Second, as McDaniel and Turner proposed, an appropriate logic for the ways of being thesis is many-sorted. Even in the mathematical tradition, many sorted languages are introduced for the sake of formalizing mathematical practices in which there are types of entities that interact with each other, such as in geometry or in second-order logic. The worry is that if QV is to be embedded in a many-sorted language, then QV amounts to nothing more than a variety of ways of being thesis, which is one of its rivals. So I guess it's like saying maybe it's just kind of like a modal thing going on here. You just got different modalities. The major confusion here is similar to the first worry. The sameness of logic is one thing, while the sameness of philosophical theories that use the logic is another. For example, free logic is favored both by Meinongians and by the proponents of ways of being thesis. This fact by itself does not necessitate that the ways of being thesis be a kind of Meinongianism. Far from it. The mathematical equivalence of or sameness of logics deployed by non-identical theories does not make such theories identical. It may well be that for the purposes of variantists and proponents of the ways of being thesis, the best language and the logic is many-sorted, yet these two theories are not the same. The third object is that utilizing a Kaplanian character in the context of QV is nothing but a formal trick, since one can adopt the strategy to argue that any two irrelevant meanings have something in common, provided that they have a shared expression. For illustration, consider how we can argue that there is a shared factor between different meanings of bank. So just ambiguity here, I guess. Define a function from bank to its different meanings as follows. The function takes one and gives the first meaning, the land alongside a river, and takes two and gives the second meaning, a financial establishment. However, it is silly to conclude that different meanings of bank have something in common because of the existence of this function. But it is the worry continues that preclude the extending the suggested strategy for the meanings of quantifier expressions, which is allegedly good, a good case, to an arbitrary case such as bank, which is clearly a bad case. Thus, the challenge of determining how bad cases could be distinguished from good ones. Yeah, well, that's the question. Although I have no criteria that discriminate good cases from bad ones, there are reasons to think that the current case, namely the existence of a common factor between quantifier expressions, is a good one. I have argued that QV is better be embedded. Don't understand. I have argued that QV is a better embedded in a many-sorted language. The whatever. I know what they mean. The benefit of this embedding is that the quantifier in different languages turn to be a sorted quantifier in the unified language. I then propose that the information carried by sorted quantifiers can be divided into two parts, sort and abstract quantification. The information implied by the abstract quantifier is associated with abstract rules which are literally shared by the sorted quantifiers. This is exactly part of the information that explains why the sorted quantifiers are quantifiers. Okay, yeah, this is a slight problem here. Not terrible. This is basically restating the thesis, and so they say, look, this is basically saying, look, of course you can say there's bad cases, but if you already think this is a problem, the QV issue and the MV issue are problems, this is a solution to the problem, and so you already sort of believe in this sort of issue and how this is of significance. And so that's really kind of what I think is behind this paragraph. It's not that you have no criteria, it's that you already had, in some sense, the point of this paper is that you did have a criteria to begin with. And so this is just reiterating the main point that of what's going on. So it's like, sure, you could call this a bad case, but that's rejecting the problem to begin with. And that's, if you're interested in the stuff, you wouldn't do that. So that's really, I think, how to respond to this sort of question. So I don't think this answer here is super great, but like the point still stands. It's like the intuition of the author is correct. I just don't think they phrased it particularly well. Okay. There is a substantive asymmetry with the case under considering cases such as bank is correctly suggested by the objection that seeking a common factor between the meaning bank by appealing to the defined function is silly. Well, don't call people silly. That's not nice in philosophy papers. I mean, if I call you silly here, it's because I'm an idiot. But I can say I don't think this argumentation was great, but it's just whenever I read a paper and they say something like this, it almost inevitably comes back to bite someone in the butt. Don't insult your interlocutors. It's just not worth it in philosophy. Just a general point in having read a bunch of these things in philosophy in general. However, I don't intend to adopt that suggestion. The case of quantifier expression is far from cases like that of bank. As I've illustrated, in the case of quantifier expression, there is really a common factor that is manifested and made explicit by means of abstract rules, which explains the expression is a quantifier. A parallel structure is missing in cases like bank. However, the concessive nature of this answer should not be sidestepped. I have not and do not intend to propose criteria that discriminate good cases from bad ones. Actually, there is no need for such criteria when there are reasons to think that the case under consideration, that is the quantifier case, is a clear case of a good instance. Okay, again, this is the same issue as above. It's that if you're reading this paper, you already agree with that. Now, you can go to the foundations of this problem and then try to sort that out from the foundations of ambiguity in bank, which is a much different problem than what's going on, and you can do that. Like, you could go look into the history of the word bank and the logic of it, but then sorting that out is a completely different problem, and I wouldn't call that silly. Because if you have a solution to ambiguity, then you'll make your name very quickly in semantics. The fourth objection is based on suggestions by Turner and McDaniel. They suggest that one can define an inclusive quantifier by means of assorted quantifiers. Okay, some logic stuff. So, it looks like a disjunction here. Yeah, so it's one or the other. Okay, so you just have a long disjunction that it's, for exists phi, then there's one, it's either this one, or sorted 2, or sorted 3, or sorted 4, whatever kind of sortedness it is. This definition introduces an x as a variable that can be assigned to any sorted thing in any sorted domain, and the quantifier backwards e binds x. The worry is that there seems to be no difference between this defined quantifier and the abstract quantifier, since both seem to be equivalent to the disjunction of sorted quantifiers. Yeah. If the abstract quantifier is nothing but the defined quantifier, QV would collapse into ontological realism. Here is an alleged explanation. Following the Quinean meta-ontological slogan, to be is to be a value of a bound variable of an existential quantifier. The defined quantifier thus has ontological import. The domain of the defined quantifier includes all the sorted domains of sorted quantifiers. Thus, the ontological import of the defined quantifier includes the ontological imports of all sorted quantifiers. Adding this claim to QV entails that the ontological question, what is there, has a unique answer. All that is committed to in the different languages. That is to say, QV is nothing but ontological realism in disguise. Yeah. Actually, one can resist this line of argument in more than one step. First of all, one may prefer an anti-Quinean meta-ontology. This should not appear to be ad hoc, since QV is originally suggested by anti-Quinean meta-ontologists such as Hirsch. Here I pursue a more conservative answer, however. In order to deflate this worry, it suffices to realize that the abstract quantifier is not the same as the disjunctively defined quantifier. Well, why not? There are substantive differences between them. First, the defined quantifier ranges over a domain of quantification, namely the union of sorted domains. This is not the case for the abstract quantifier. As implied by their definitions, only sorted quantifiers have domains. The abstract quantifier is not associated with any domain. Well, it's associated with all the sorted stuff. It has different sorts of objects. That the abstract quantifier has no domain explains why the Quinean meta-ontological slogan, even if assumed, is irrelevant for the abstract quantifier. I'm not sure about that, because you have these sort of meta-objects, and so, I mean, the worry that I have is that maybe it's just a little sleight of hand, then, that you're saying, well, it doesn't have any objects because it takes other quantifiers. But is that a meta-variable that exists then, and then that just sort of, it does have stuff. It does have domain. It just, the domain's a very strange domain, but like it's still a domain. Okay, so I don't know if that makes any sense, but yeah. The second difference is conceptual. Since the defined quantifier is defined by means of sorted quantifiers in disjunction, its concept is determined by sorted quantifiers. The sorted quantifiers are conceptually prior to the defined quantifier. The direction is reversed in the case of the abstract quantifier. As declared before, the information in the sorted quantifiers is divided into two factors: information about quantification and information about sort. The proposed regimentation of the first part of the information is abstract quantification. This suggests that the concept of sorted quantifiers are partly determined by the concept of abstract quantifier. The abstract quantifier is thus conceptually prior to the sorted quantifiers. Again, same sort of worry as before, that this is I mean, I'm still thinking it's a little ad hoc. I don't know if the ad hoc has been completely gotten rid of yet, but I mean, again, the devil's in the detail, so I'll take the author's word for it here. The second difference between the abstract quantifier and the defined quantifier explains why the abstract quantifier, but not the defined quantifier, provides a basis for solving the problem of meaning variance. To solve the problem, there must be a shared factor between alternative existential quantifiers. Although the abstract rules governing the abstract quantifier present themselves as shared factors, the rules governing the defined quantifier cannot play such a role, since the defined quantifier has a disjunctive nature. This fact amounts to a third difference between the abstract quantifier and the defined quantifier within the context of QV. They have disparate explanatory roles within the respect to the problem of MV. Okay, that's fair, that because of the way it, but see, this would make me worry that because it does this, shared factors, and that's what makes for the abstract variables that, like the second order variables that take the other quantifiers. So I'm a little worried about like this shared factor as defined, because isn't that how they had those like alphas or whatever it is that refer to the other objects that are the sorted quantifiers and sorted objects. So yeah, okay. These are details that probably can be worked out, but I mean, it seems fine. In this paper, I concentrated on the problem of meaning variance for quantifier variance. What is the common feature of various quantifier expressions in virtue of which they are all quantifiers? A ready-made candidate already suggested by Hirsch is the set of formal rules governing them. However, this candidate is susceptible to the collapse argument. I argue that one reasonable route to overcome the collapse argument is to embed quantifier variance into a many-sorted language. The meaning variance problem, though, remains intact. Thus, I propose a Kaplanian solution to the problem for many-sorted languages. The solution is to regiment the quantificational features of sorted quantifiers as the abstract quantifier. The idea of abstract quantifier fit well in Eli Hirsch's original comment. I propose that the shared formal rules are the introduction and elimination rules for the abstract quantifier, hence a Hirschian variantism. Okay. Sorry. Alrighty, so this seems pretty good. I mean, all these arguments, this is a sort of philosophy that can be argued over plenty. The devil is always in the details, but like, yeah, so you can work that stuff out. Yeah, all this stuff, you know, it's just a nice way to organize this sort of argumentation in this sort of sorted logic. And so I think it's a reasonable proposal in this area. If you're worried about this sort of problem of like trivialization and what different sorts of things there are in this world, if you're going to hold that the quantifiers means there exist, but then things exist in different ways, and so how do you actually sort that out? And then you just give a sorted logic. Again, the biggest problem was in the alleged issue at this last part with Bank, is that the whole thing about the sorted logic with the sorted stuff is that there's going to be some ambiguity there, and how do you handle the ambiguity? Now that's always a difficult problem, and the author, of course, said, look, this is a good solution to a good problem, and I agree with the author. It's just this is a bigger problem here, and it's the fact that they didn't solve that's fine. That's not the goal of this paper. But how do you actually solve the problems of ambiguity and value within logic? Like, what exactly is of ontological importance, and how that's being described in logic is just difficult. I mean, it's just difficult overall, not just for logic. So that there is about it. I hope you enjoyed this. If you have any questions, please let me know. Otherwise, have a happy and safe day. And I'll be back, I guess, tonight, Yeah. So, and have fun sorting out everything.